So it's been a while since we've seen each other. I didn't bother reprinting the calendar because it's going to be, it will agree with the calendar that I gave you last time soon enough. So it's just up here and it'll be slightly different from what you have on paper. So we had our second snow day of the semester on Friday. The class before that was the quest. I've given all the quests out, but I can't give them to you to keep until next time. So if you can put them back in the green folder face down as soon as you finish looking them over, I would appreciate that. I'll give you the quizzes to keep next time, but I need them back today. Put them face down so nobody else needs to see your grade. Okay, so we had our snow day on the 14th, which means I took everything and I shoved it down one day, except there was a day right before, where are we here? Quest number 2. There was a day right before quest number 2 on the original calendar called Catch-Up Day, and that was a day kind of built in just if we needed to slow down a little bit and catch up. Okay, well, we have lost that catch-up day now because we have our second snow day. So quest number 2 is on everything of classes 6 to 11, but 11 is now doesn't exist anymore. So it's just on classes 6, 8, 9, and 10. 4 classes worth of material. So our next quest is as scheduled originally on February 26th, and this is what the calendar looks like. Any questions on the calendar? So today we're going to talk about additional properties of lines. Next class we'll talk about lines of best fit, and then the third class from now is in context linear problems. You can see lines are the next 3 days, and in context means word problems. So let's jump in here on page 45. We'll go up here at the top. And it says we start today by exploring horizontal and vertical lines. So these are some kind of special lines that we'll talk about, and their equations look a little different than the normal like mx plus b equations. So on page 45. So first thing says, consider these points, 7, 2, negative 4, 2, and 0, 2. What do these points have in common? The same y value, right? What's the y value for all of them? Y equals 2. In all of those points, right? Same y value. Okay, take a moment to plot all 3 of those points over here on these axes. And then draw the line that connects those 3 points. And what word describes the line you just drew? Which one is it? Horizontal. Horizontal. Okay. So thinking more about that purple line that we just drew, every point on this line has the form blank comma blank. Okay, well, what was in common for all the points that we plotted? The y was 2. So would you agree that every point on this line, like any point you pick out there, 100 miles to the right, the y is definitely going to be 2, right? All those points are 2 units right above the x-axis. So it's definitely a 2 there. And I'll just put a generic x in the first slot. It could be anything, but it's definitely a 2 for the y. Moving on to E, it says find the slope of the line connecting these points using the slope formula. So let's give that a shot. What's our letter for slope? M. You're off today. I don't know. It's the snow day is really throwing you off. All right. So the M. So we'll do our y2 minus y1, right? This formula over x2 minus x1. And we have 3 points up here to pick from. I'm just going to arbitrarily choose the first 2. So let's go ahead and do the change in y over the change in x. To find the change in y, what am I subtracting? 2 minus 2 over negative 4 minus 7. It's okay if you said that in the other order. Upstairs we get 0. which means downstairs doesn't matter a whole lot, but we'll put a number. Negative 11. It's okay if you put positive 11. What is this really equal to? 0. So the slope of this horizontal line is 0. And in fact, the slope of every horizontal line is 0, because upstairs you're always going to do a change in y, but the y is always the same on any horizontal line, right? I'm not saying it's always 2, but if you had a line that was 1 unit higher, then the y would always be 3. And when you subtracted those 3's from each other, you'd still get 0. Another way to say it is that the rise is always 0, right? You don't rise at all going from one point to another on the horizontal line. Okay, and one more thing that kind of makes sense about the slope being 0. What did we say about slopes of uphill lines? What's true about the slope of every uphill line? They're all positive numbers, right? And what's true about the slope of every downhill line? They're all negative numbers. And what's the only line that's in between the uphills and the downhills? Is a horizontal, right? Well, there's actually, yeah, you could also argue that vertical is in between. I'm gonna say go from the downhills to the uphills. So we're kind of swinging around like this. And the only line in this list that isn't downhill or uphill is horizontal. And what's the only number between all these negative slopes and all these positive slopes? 0, right? That's the only number between the negatives and the positives. So I think it makes sense that the slope is 0. All right, let's get rid of all this stuff. Zach. Yeah, so left to right is always how we walk. That's a downhill, which is a negative slope, and then left to right is an uphill or positive slope. Yeah, always left to right. Yeah, they go forever. So I'm just drawing little slices of these lines. Good question. Okay, and then finally down here, part F, says write an equation for the line that passes through these points. That's our horizontal line that we drew. Again, what was the commonality for all those points? What was 2? The y was 2. So the equation of that line is plain old y equals 2. Okay, so to summarize, we just discovered a lot of stuff about horizontal lines. First of all, the slope of any horizontal line is what number? 0. And the equation of every horizontal line is always of the form y equals some number. Every horizontal line is y equals some number. So it's not going to look like y equals mx plus b, although if you're paying attention, it actually does. Because if you're horizontal, we just said the m was how much? 0. And that means that this 0x I don't need to write because it's nothing, which means the equation of any horizontal line is y equals b, where b is what magic number? Is the y-intercept. And what's the y-intercept for the line that you drew? It was 2, of course. Every y value was 2 on that line. So yeah, it agrees. Y equals the y-intercept is 2. Okay, so that's everything there is to know about horizontal lines. In number 2, we'll talk about vertical lines. So taking a look at these 3 points, 4, 2, 4, 5, and 4, -3. What do they have in common? Which one is 4? X is 4. Go ahead and plot all 3 of those points. And then connect the dots with the line. What's that? Is it what? Yeah, you could argue that actually. We're going to call it something else, but you could make a case for what you said. Okay, what's true about this line? It's vertical. Okay, so we can fill that in here. Vertical. Okay, every point on this line has the form something comma something. Which one of them is always the same? The x. And what was it in this case? It's 4. So these points are all the form 4 comma something. I'll put a generic y in there because I don't know what it is. But every point on that line, 4 comma something. Let's go ahead and find the slope. I'll choose the first 2 points to find the slope, but you can pick any 2. And if you've come in late, have a look at your quest, but then put it in the folder for me. I can't give them back to keep just yet. But throw it face down in the green folder when you're done looking it over. Okay, so let's do some slope calculating. Y2 minus Y1, what am I subtracting here? The 5 minus 2, or the other order is fine. Over, and then we subtract the x's. What am I subtracting? 4 minus 4. Upstairs doesn't much matter, it's a 3 in this case. Downstairs, 0. 3 divided by 0. What can we say about that fraction? Is it 0? It's undefined. Right, we know we're trained from a young age, you cannot divide by 0. So the slope here is undefined. And this is something that's true for every vertical line. Because remember, vertical line is a rise over a run. Now going from one point to another, you can rise, I don't know how much, 3 in this case. But how much are you running left to right if you stay on that vertical line? Nothing at all. So every time you do the slope of a vertical line, you're going to end up dividing by 0 because you don't run at all left to right. And whenever you divide by 0, slope is undefined. Mariah, what did you say? What did you guess the slope might be? Is it infinite? Mm-hmm. It's true. Yeah, and I think, yeah, and you could make the argument that instead of calling it undefined, you could call it infinity. In fact, I'd give full credit for the answer of infinity. I think it's great. We talked about uphill lines, so like that might be a slope of 1. This one might be a slope of 2. Maybe this one is like a slope of 8. And what's happening is these lines get more and more vertical. What happens to the slope? This was a 2. That's maybe, well, this is a 1. That's maybe a 2. That's like a slope of 8. What's happening to those slopes? Yeah, the lines are getting closer to vertical. What about the numbers for the slope? Bigger and bigger. And if they go forever, then infinity is a good name for that last slope of the vertical line. Yurka. I don't want to call it unknown because that might give the impression that like somebody could calculate it, but we just don't know how to. Nobody can calculate this thing. We should either call it undefined or, because of Mariah's suggestion, infinity is a perfectly good answer. That said, if you move on to another math class and you put infinity, that might not be a perfectly good answer. So undefined is the safest one if you're remembering stuff. Okay, and then finally F, an equation for the line. Well, we've written it before. Which letter was the same for all 3 points? X, and how much was X in this case? 4. So the equation of that line is X equals 4. Okay, so big conclusions down here. The equation for a horizontal line has the form. All right, horizontal lines. Are they x equals or are they y equals? Don't guess. Look up and find the right one. Horizontals are y equals. So I'm just going to put y equals and then number sign. And the slope of every horizontal line is 0. Now the same things, but for vertical lines, what's the equation of every vertical line? X equals some number, and the slope of every vertical line, undefined. Now, in the coming quest, I'm going to ask you guys questions about vertical and horizontal lines. Write the equation of a horizontal line that satisfies blah, blah, blah. And some of you are going to know, oh, horizontal line, that's y equals, and you're going to get it right. And some of you are going to be not sure, and you're going to guess. It's a 50-50 shot, right? Can't get much better than that. But don't guess. All you have to do is figure it out. You can figure this out on the fly. Draw yourself a horizontal line or draw yourself a vertical line and just pick a couple of points. Oh, this is the 0.45. This is the 0.42. Oh, x is the same. X equals 4 is the equation of that line. It takes like 10 seconds to avoid having to guess. So if you're at all unsure, you don't need to rely on some kind of foggy memory that you're developing right now. Just figure it out on the fly. It's quick. All right, let's move on. We're going to skip 4 and move on to, well, we'll skip A and B, but we'll move on to C on the next page. So this is a pretty typical test kind of question. Write the equation of, put that up here, these were the directions for all of number 4. Write the equation of a line that has undefined slope and passes through the point 5, -7. All right, undefined slope. Undefined slope, is that horizontal line or is that vertical line? It's vertical. Vertical line, is it x equals some number or y equals some number? It's x equals. Okay, this is half the battle. We've already figured out it's x equals some number. There was a little bit of detective work we had to do to get there, but don't guess. Work your way through it. Okay, I needed to hit the 0.5, -7. If it helps you, feel free to plot the 0.5, -7. But all I know is I'm looking for the value of x at that point. What is it? It's 5. We just grab whatever the right coordinate is. So x equals 5 is that vertical line, undefined slope, and it hits the magical point. Part D, I want a line that has an m equal to 0 and passes through the point 32. Slope equal to 0. Is that horizontal or is that vertical? Slope equals 0 is horizontal. Horizontal lines, are they x equals or y equals? Y equals. Again, that's half the battle. And how much is the y at that point? It's 2. So y equals 2 is the equation. Any questions on horizontal and vertical lines? So we have now seen everything that I expect you to know how to do, everything I expect you to know about horizontal and vertical. There's not a lot to them, but it's really easy to have a murky idea of what you're doing and then like flip a coin and pick wrong. All right, moving on to 6. What word would you use to describe the lines that are graphed at right? We've got 3 lines sitting there. They all have positive slope, definitely. What other word for the 3 lines all together? They're parallel to each other. Yeah? So you guys know the word parallel, right? It means 2 lines that never hit each other. Okay. Next question says, what do the equations have in common? So let's focus our attention on the 3 equations that are written up there at the top. Y equals 2x plus 4, y equals 2x minus 1, y equals 2x minus 8. What's the same in all 3? Is the slope, is that 2? And it kind of makes sense that if your slope is the same, you'll be parallel. Because the slope is just telling you, okay, you know, you're gonna rise some amount and then you're gonna run some amount. And if I do that exact same triangle on some other line, then I have to be describing lines that are rising and running in the same way. They have to be going uphill in the same way or downhill in the same way. They got to be parallel to each other. So the equations have in common the same slope. And then our conclusion is that two lines are parallel if their slopes are equal. And then if we wanted to write some kind of equation, if we say M1 and M2 are the slopes of two different lines, then we're saying that M1 equals M2. Two lines are parallel if their slopes are equal. All right, so that's an important fact for today. And let's see if we can run through number 8 here. All right, so it says the graph of 3x plus y equals 1 is shown on the axes at right. And what we're going to do is write an equation for the line parallel to that line that passes through the point -2, 1. So I'm going to plot the point -2, 1. You don't really need to, but it might help us to visualize a little bit. So there's the point that I want to hit, and I want to be parallel to the line that's given, so I'll just estimate, just kind of eyeball very poorly and try again. So we just want some line that's parallel-ish to the line that's given and hits the magic point. Okay, so here's the process. In order to find the equation of the blue line, which is the goal of this whole problem, find the equation of that blue line. We need a couple of pieces of information, but definitely one thing we need to find the equation of any line is the slope. We always find the slope. So how are we going to find the slope of the blue line? What's that, Boo? Okay, so we have the blue line here given, but I've just estimated the, this parallel idea. Really, we don't know a whole heck of a lot about the blue line. We have a lot of information about the black line. Yurka? Mm-hmm. What do you want to substitute into the equation? The point. Okay, well, that's an idea. Right, couldn't we take this point and substitute it in to that equation? Let's try that. So 3 times the x plus the y equals 1. So let's plug it in and see what happens. So what do we get here? 3 times what number? -2 plus the y value, which is 1, equals 1 according to this equation. Does it? -6 plus 1, that's a -5. It doesn't equal 1. Are you surprised that that point doesn't satisfy the equation? Yeah, the y-intercept is different. That point shouldn't satisfy the equation. Take a look at the green point. It's -2, 1. Is it on the original black line that's drawn up there? No. Then that black line is the one whose equation is given. So it better not satisfy the equation because it's not on the line. So the green point is going to satisfy the equation for the blue line. Unfortunately, we don't have that yet. But I like the idea of plugging in. That's a very natural thing to try. Yes? Yeah, we're going to end up using point slope. That's what we'll do. So first thing we need is the slope of the original line. This is the slope of this black line here. In fact, I'll use black for this. So we're trying to find the slope of the only line that we're given. Okay, you could count boxes if the picture is given to you, but probably on the quest, I'm not going to give you the picture. It's just going to be the line. So let's make sure we know how to do it with the equation and not necessarily the picture. How do I find the slope of this line? Why are you subtracting 3x, Alan? Yeah, we're trying to isolate the y, right? If it looks like y equals mx plus b, then we're looking at the b. Or sorry, we can grab the slope. So let's solve this equation for y by subtracting the 3x. So what is the slope of that line? -3. So I'm going to write this is the slope of the original line to separate it from the line that we're trying to think about, the blue one. So the slope of the original line is -3. What does that mean about the slope of our line that's parallel? That's also -3, because we've already figured out that parallel lines have exactly the same slope. So not only is that -3 the slope of the black one, but it's also the slope of the blue one. Okay, so let's jump in here. I said use point slope form, but it seems like we're using the slope intercept form almost exclusively. You're welcome to use point slope if you want. That's the y minus y1 equals blah, blah, blah. Okay, let's fill some stuff in here. How much? Okay, so let's just establish the slope first. What's the slope of our line, blue one? It's -3. So I'm just going to rewrite the m and call it -3. Okay. And getting that -3 is really all the black line was good for. I don't care anything at all about any other property of that black line other than the slope, the -3. So this y-intercept, what is the y-intercept of the black line? Of the black line is 1, right? The y-intercept you can see here is 1. You can also see it here as the +1 from the equation. It's very tempting to grab that +1 and shove it into the equation we're finding here, right? That is a y-intercept, and so it's kind of natural to throw it in for the b. But it's not the y-intercept of the blue line. It has nothing to do with the y-intercept that we're after. So we don't use it at all. What we do is recognize that the point, the green point, -2, 1, is on the blue line. So let's use it. -2, 1 satisfies, I'll circle it here in blue. It's got to satisfy the equation we're after. So let's plug it in. So instead of the y, 1 equals -3 times, instead of the x, 2. -2, thank you, -2. Plus, how much is the b? It is unknown at this moment. It's really tempting to put a 1 there. The y-intercept of the original line has nothing to do with the y-intercept that we're after. So we don't get to plug it in. Okay, so this says that y is equal to 6 plus b, so how much is b? -5. So I think we're ready then to write our final equation. Y equals -5. Great. Was my blue line up there very accurate now that we know the y-intercept should be -5? Not really. I was off by a little bit, right? Looks like my y-intercept is maybe -3. But I can believe that it should have been down here at -5, something more like that, because my line, it kind of tailed into the line that I was trying to be parallel to. So I should have drawn it more, something like that. So -5 is perfectly reasonable, and that's our equation. Any questions on the process? The -5 comes from solving the equation. So did you buy where that equation came from? Yeah, so then multiplying, yeah, so then subtract 6 from both sides. Yeah, that gives us there. Okay, so that is that. When we're ready, move on to the next page. And there's one more kind of relationship between lines that we're interested in today. And that relationship is between perpendicular lines. So I've graphed 2 perpendicular lines here in this picture. What does it mean to say that 2 lines are perpendicular? It means they meet at right angles. It means they cross each other kind of in some symmetric way. Like I could draw 2 lines that cross each other like this. Are they perpendicular? No. And so we can kind of look at angles and we can say, well, that angle is kind of small compared to this one here, which is a lot bigger, right? So they don't meet each other in like a perfectly symmetrical way. But the 2 lines that are drawn in this graph, they do meet each other in a symmetrical way because that angle is exactly the same as that one, which is the same as that one, which is the same as that one. And Karen, you had used the word, what are all these angles called?
Right.
They're all called right angles. How do we normally measure angles? What's the unit? Degrees. How many degrees is in a right angle? 90 degrees. So all of those angles are 90 degrees each. That's what it means to be perpendicular. 90 degrees. Okay, so I've given you some more information here. The points 0, 4, and 3, 2 lie on L1. That's the decreasing line. 0, 4, and 3, 2 are both plotted there in red. And then I gave you a couple of points on the other line. And what I'd like you to do now is find the slopes of those two lines using the 4 points that I've given you. So go ahead and do 2 slope calculations for those two lines. All right, so let's take a look at these two lines. So we've got a slope of -2/3, that's the downhill one, and then a slope of +3/2 is the uphill one. So there's a lot of stuff in common there. So first of all, what can you say about the signs? What's true about the signs? Are they the same or are they different? They're different, right? These are opposite signs. And that makes a lot of sense because if you have two perpendicular lines, doesn't matter how you have them, one of them is definitely going uphill and the other one is downhill, right? I mean, unless it's perfectly horizontal and vertical, which is like a special case, like no matter how you draw your two perpendicular lines, one's going up and the other's going down. So one slope is positive and one is negative. So I buy that. But then there's this other relationship. 2/3 became 3/2. What's the fancy math word for flipping over a fraction? Reciprocal. And turns out this is true all the time. If you have two lines that are perpendicular, then their slopes are opposite signs, one positive, one negative, and reciprocal numbers, 2/3, 3/2. So that is written down here in number 10. It says if two lines are perpendicular, then the slope of one line is the negative reciprocal. Some people wrote opposite reciprocal, that's great, of the slope of the other line. And if you like equations, then I guess we're saying that the slope of one line, M2, is negative, that's the opposite part, and then 1 over, we know that's how we flip a fraction, right? By doing 1 divided by. So -1 over the other slope. So let's see if we can play detective here in 11. Again, another standard test question. Write the equation for the line that's perpendicular to y equals -3x minus 2 and passes through the point 1, 3. So there's a lot of info there. We have to be able to figure out how to pick and choose the relevant information because not all the info in this problem is relevant. Okay, so I see perpendicular. Does that mean the slopes are the same or opposite reciprocals? Opposite reciprocals. Those are the only two choices. We talked about parallel slopes are the same and perpendicular slopes are opposite reciprocals. So what we have to do is take a look at the slope of the original line. I always like to distinguish the original line from the one that I'm being asked to find. So this one's already written in a very nice form. What is the slope of the original line? -3, right? Because it already looks like mx plus b. So that means the slope of our line, the one that we're asked about, is what? -1/3? +1/3. So you got to do two things to the slope. You have to change the sign and you have to flip it over. So it used to be -3. The answer down here is definitely going to be positive something. And it used to be 3, flipped over. We know that becomes a third. So I'm going to put like a little line through this line right here. We are finished with that line. We used the slope to get the slope of our line. What didn't we use in that line? That -2, the y-intercept. The y-intercept of that line has nothing to do with the y-intercept of the line we're trying to find. So it's time now to use this other info, this 1, 3. So we'll write down our standard mx plus b. We'll fill in the slope. We just figured it out. What did we say here? So that's a 1/3 x plus b. And now we're going to use the point that we're given and plug in. How much is the y? 3 equals 1/3 times, how much is the x? 1 plus, how much is the b? We don't know. It's really important to recognize that we don't know, because you're plugging into an equation. And it's really tempting to try to take all the information in the problem and plug in. And there's a b sitting in this problem, right? I've crossed it off with the green line up there. But there is a b staring at us, waiting to be used, but it's irrelevant. The b that we're interested in is one that we don't know, and we use this equation to find it. Okay, so 3 is 1/3 times 1 is just 1/3 plus b. I want you guys to find the b here. Just on the first quest, some people show a clear preference for mixed numbers. If I subtract 1/3, what does that give me as a mixed number? I had 3 and I'm subtracting 1/3. It's 2 2/3 is what I have. That's called a mixed number, 2 2/3, because you got the whole number part and you got the fraction part, so it's mixed. Mixed numbers are hardly useful in a math class. Improper fractions are what we're after here. So if we wanted to subtract, I'll do it on the side here, 3 minus 1/3. No, it's not a multiply, but we do need to find a lowest common denominator here. Oh, maybe that's the 9 you were talking about, Zach. So, no, we cannot do that. This is a subtraction, right? To move that 1/3, you have to subtract. Okay, so how many thirds do we have here? 8/3. So that's called an improper fraction, and it's far more useful in terms of doing something with it than a mixed number. 9/3 was kind of a miracle. What we had to do was, so we had this denominator of 3. So we need to get this guy over here to have a denominator of 3. So just change 3 into 9/3. Yeah. Okay, so then I think we're just about done. So that means that the equation of our line, I guess, can come from here now. Y equals 1/3 x plus, and then we just did all that work to get the b. Turned out it was 8/3. Ta-da. So that's the equation. Questions on that? Victor. Mm-hmm. Three equals 1/3. Oh yeah, we're not moving the 3, we're moving the 1/3. So this guy right here. We need to solve for b, which means getting that 1/3 out of the way. And we do that by subtracting 1/3 from both sides. And that 3 minus 1/3 on the left-hand side is what we were interested in over here on the side. Okay. Other questions? Okay, to summarize, we talked about some special lines at the start, horizontal and vertical. I need you to know what their slopes are, and I need you to know the special forms of their equations, right? They're not y equals mx plus b. They're either x equals a number or y equals a number, and you got to keep them straight without resorting to flipping a coin. And then we talked about relationships between two different lines that could be parallel, in which case their slopes are equal, or they could be perpendicular, in which case their slopes are opposite and reciprocal, or negative and reciprocal. Okay, so skip 12 and come back to it if you have time. But what I'd like you to do now is go to the group activity. Starts in the middle of the next page. Answer key follows. Raise a flag if I can help. I'll come around and check homework and see if there are any questions on this activity.